This is Amateur Logic, episode 113 for January 15th, 2018. This episode of Amateur Logic was brought to you by MFJ, the world leaders in ham radio accessories at mfjenterprises.com, and by Icom. Start the new year out right with a bang with one of Icom's new radios. Hi, welcome to another episode of Amateur Logic. I'm George.
I'm Tommy.
I'm Peter.
And I'm Emile.
And it's good to be back with you, although, boy, it's going to be a bumpy ride tonight, I'm afraid. So just hang on. If you've got something solid you can grab, then do so. If not, put one foot out on the floor, and I think you'll make it okay. Tommy is not over here tonight, but Tommy, tell us what's going on here.
Well, I caught a little bug this week, and afraid I might have been a little contagious, so I didn't want to give that to George and his family. So we're going to try to shoot my part remote this time.
Yeah. See
how that works out. Should be interesting, although it is going to present a few extra challenges, I see.
Yeah, well, particularly over here, it's going to be a pretty good challenge. So we're just going to have to see how it goes. I'm sure we'll get it, and might be some broken limbs or something, but I don't think anyone will die in the process.
I should have put on one of those biohazard suits and just came on anyhow.
Yeah, you should. But me and my family do appreciate you doing this remotely, and your new camera looks good too.
Oh, cool, thanks. Yeah, I got it just for the occasion.
Yeah, cool. Well, Peter, what have you been up to recently?
Well, I've had a couple of days off work with probably the same bug that Tommy's got. So it's just as well I'm on the other side of the world as well. So, but apart from that, though, I've actually spent most of the week doing research into a possible lost tribe of Dutch survivors from a shipwreck, which predates European settlement in Australia. Quite bizarre, but looking into that, quite an interesting topic.
Cool, that does sound quite interesting. By the way, I do want to mention, and we always do, but anytime we're doing a show, shooting it during the live streaming event there, we've got a chat room going on, AmateurLogic.TV/chat. You can go there and catch up with the folks in there, chatting back and forth, kind of feeding us information that we may or may not see if we're looking down at the screen. I'm watching them right here. So every now and then we'll see something good in there and bring it to our attention. But basically they may be heckling us in there. We don't really know what they're doing at all points, but they're having a good time. So if you're watching live, go to AmateurLogic.TV/chat also if you've got the capability there, and join in the chat room.
Yeah, if you're not in the chat room and you're watching the live stream, you're missing a big part of the fun.
Yeah. Emile, what have you been up to?
Well, it is been unusually cold down in the swamps of southeast Louisiana, so I started putting some of my own amateur into the sciences, and I've been messing around with some weather fun down this way since we got to play in the snow, which is unusual for us, and been having fun with that.
Yep. And speaking of the snow, we may have some here Tuesday, Tommy. I just saw on the weather a while ago.
Oh, great. Well, I'm getting out of town just in time then. Of course, I'm going up to upstate New York. I'm sure there'll be plenty up there as well.
Oh, I'm sure there will. And we'll probably be getting some bodies down here because we don't usually get that much of it, and we've already had some this winter. So we'll have to get back with you on that one. Emile, we might send some down to you as well.
All right, appreciate it. That's snow day number 2 for us this year.
Okay. Well, I've got an email here that I wanted to read tonight because this is a topic that comes up from time to time. It's from Ken, K-E-8-H-Z-O, and he said, "Hi, George. I have another question." He had asked me a question earlier. By the way, Ken is a new general. He got licensed, I believe, back in October, went straight from nothing to general. Took his technician and general in one setting. So congratulations on that, Ken. But he said he's got a question. He bought an Icom IC7300 after watching our demo, and excellent choice there. He says we sold him on it, and that's our job. But it really is a nice radio. I am sure you're enjoying it. He says he has a Buckmaster 7-band off-center fed dipole with a ballon that's 30 foot in the air. The ends are around 10 to 15 feet in the air, so he's sort of set up like an inverted V. He said he seems to be receiving okay, but he's been trying to transmit, and the fellows on the different bands, mostly 80 meters, tell him that that he's barely coming in. One ham asked him what he was using, and he told him an IC7300, 100 watts, and he said no wonder. And so his question is, should I be looking to get an amplifier? I just spent money on a new transceiver, and I don't want to spend another $1,000 on an amplifier if I don't have to. What are your opinions? Thanks for taking the time, and he loves our webcast. Well, Ken, I'm just going to be honest. You were this email I got back in October. There was, I'm quite certain, some lightning static still going on around the U.S. here in October. And on 80 meters, you're going to hear that at night. Well, you'll hear it during the day too, but particularly at night. And if you're trying to talk to other people on 80 meters, everybody's hearing that static. And a number, I would say a large number of some of the groups, the guys that you're hearing really well, it's a good chance they're running an amplifier. And it kind of takes that to get over some of that static. If you're on another band like 40 meters and on up, you may not need an amplifier and have pretty good results there. It's really when you get down to 80 that you're combating that noise, and an amplifier will really make a difference. Basically, if you're running 100 watts talking in the summer or during lightning season, is going to be tough. In the winter, you should be having better luck with it. But yeah, 80 meters, get an amplifier if you can, because if you're talking to guys with amplifiers, you're going to hear them a lot better than they can hear you, and it might be hard for them to hear you in some cases, although you're hearing them just as clear as day. You don't need a real big one. I would say, the first 500 watts is the most important. So if you can get at least 500 watts, that's going to be a pretty good increase in your signal out there. If you want to go to a kilowatt or 1,500 watts, legal limit, well, that's good too, but you don't absolutely have to. If you're buying an amp, the first 500 watts is the most important. What would you say, Emile?
I do have a kilowatt, George, and you're right. I probably run most of the time, especially in 75 and 80, about 400 to between 400 and 600. I rarely need the whole kilowatt, so that's what I'm thinking.
Yeah, that's what I'm thinking too. I was going to ask the question to Tommy, and I realized he didn't have an amplifier, and he doesn't really talk on 80
don't, and I
meters.
purposely haven't bought one because I just I think I kind of like the challenge a bit of making the contacts without the extra power. Now, I will say sometimes it is a little bit frustrating getting sort of outdone, so to speak, by some of the guys with the amps trying to make the same contacts. But I kind of like the ones that I make are all pretty well barefooted.
Yeah, well, you know, if you're on 40 meters or above, you don't necessarily have to have an amplifier. You can make contacts without it.
And that's where I hang out most of the time.
Yeah,
I don't really like 75, 80 meters as much.
Yeah, it's when you get to 75 or 80, I think it's going to be a bigger challenge. You know, just overcoming the noise. And if there's guys, you know, running a lot of power, you know, they've got their RF gain tightened up pretty good, so they don't hear the static. So they just might not hear you, but you can certainly still make contacts with 100 watts. Peter, you have any input?
Oh, yes, indeed. I'm actually very much in the camp of not using amplifiers. Let me explain why. You mentioned that, okay, if the other guy has got an amplifier and you've got an amplifier, you're going to hear each other better, okay? That's absolutely correct. But consider the situation where the other guy is just running, 100 watts. Your amplifier isn't going to make you hear him any better, okay? He may hear you better, but you're not going to hear him any better. So ideally what you want to do is optimize your antenna setup so that you can, it works optimally on both receive and transmit. And that's the better way to go. So, for example, using a beam, like a 3-element, 4-element beam, is a good way to go because you'll get benefits on both transmit and receive. Okay. Also, you can null out a lot of that static if it's in a particular direction. So, my opinion at the end of the day is look at your antenna setup. And I also should mention also that if you're running a horizontally, polarized antenna of any kind, make sure it's sufficiently high. Otherwise, you will, quote unquote, smush your signal and it will go straight up, which is perhaps what you don't really want.
Yeah, and that's a good point, Peter. A beam antenna, something with some gain in a particular direction helps both send and receive, and you're going to get your most benefit with that. Of course, a 75 or 80 meter beam is not really practical in most cases, so
Yep.
you do what you can. And,
so it's all a compromise, but just as I say though, playing with the antenna setup, sometimes you may find that your antenna is not set up optimally, and that by using maybe something different, an inverted V or something, you get better results. And I should also say that that's half the fun of amateur radio, is playing around with different antennas and trying to get the best out of a limited amount of power.
Yeah. Well, speaking of that, I guess you could use a magnifying glass as a beam in the project you're going to present to us tonight. What have you got here, Peter?
Well, my project, you might remember from one or two episodes ago that I floated the idea of remotely controlling the AmateurLogic sign on your desk using nothing but the magic of amateur radio. No internet, just purely amateur radio using some of the digital modes. And so you probably thought, he isn't going to really do that. Well, I am really going to do it, and I've started. And this is the first step along that road, which will take a little while to put together. But we'll start off by having a look at the infrared controls on the AmateurLogic sign and how you can make up your own infrared or work out what the infrared codes are that are being sent. Hello and welcome. This month I've been working on a project I talked about a little while ago. You will recall that in a recent episode I said I'd like to remotely control the AmateurLogic sign on George and Tommy's desk using a digital mode such as WSPR. No internet. After that show, I asked Tommy to send me a photo of the remote for the AmateurLogic sign. I searched around on eBay and found a remote and infrared receiver combination that looks similar to the one that the AmateurLogic sign uses. The reason I did this was because I need to find out the codes the infrared sender sends to the sign. I also need to know how to use and program an infrared sender. First though, what is infrared? It's basically a form of light at a wavelength that your eyes can't see. An infrared remote takes that light, modulates it, and sends it to a receiver. The receiver demodulates the transmission. A different code is sent over this link depending on which button you press on the remote. Sounds simple. However, when I tried to hook up my infrared receiver to my Arduino, I found that several libraries didn't work for me. I finally found one that did work, which I'll demonstrate shortly. First though, here's the infrared remote and receiver combination I purchased. The wiring is very simple. The little board that comes with the setup is simply there to turn on an LED when power is applied to the infrared receiver. The receiver has 3 pins and faces away from the LED in the manner shown. The wiring on the little board is simple also. VCC goes to +5 volts on the Arduino, ground to ground, and the pin marked D0 goes to pin 11 on the Arduino. Before installing any Arduino libraries, you should update the Arduino IDE software, which you can find at www.arduino.cc. Next, you'll need to install a library by a chap called NicoHood. You can get his library at github.com/NicoHood/IRL remote. Download the zip file and then unzip it into your Arduino/libraries folder. Next, start the Arduino IDE and go to Examples in the menu. You should see some extra example programs have been added. The one we want to use is called IR Receive Demo. Select this program and then upload it to your Arduino. Next, open up the serial monitor and select 9600 board. You're now ready to roll. Take your IR remote, point it at the IR receiver, and press a button on the remote. You should see a code appear on the serial monitor. Different keys will generate different codes. We can now take those codes and, using an IR transmitter, use an Arduino to control an infrared-enabled device like a TV. Once we know what button is related to what code, generating the right codes to mimic the remote should be quite simple. I've now asked Tommy to use a setup like mine to record the codes for the AmateurLogic sign remote. Once I have those codes, I'll move to the next stage of my project, which will be using an Arduino to send infrared codes. But that will have to wait for a future segment.
That was really cool, Peter.
Yeah, well, it's as I say, infrared is relatively easy, and as you'll see, I'll follow this up with my next segment or a future segment, where as soon as I receive the transmitter I've ordered, where I actually take those codes and actually use it to turn on a TV or something like that. After that, we then move to the next stage, which will be doing the programming of a Raspberry Pi, and the Raspberry Pi will tell the Arduino, or it'll receive signals using, say, WSPR, and then when it's received a suitable command from me here in Australia, then it will tell the Arduino, send this command or that command or whatever. I'm probably overkilling it using both a Raspberry Pi and an Arduino, but it's simpler to implement at the end of the day.
Yeah.
We're on our way, George. I can't wait to do the show from Mars.
I hear you. And I've got another way you could remotely control that sign, Peter. Just say go.
Just what, sorry? Just say go?
Yeah.
Well, it's got voice command, has it?
Yeah. I'm decoding it right here.
Well, I want to use amateur radio, though, because I've got to sort of keep in with the theme of the show.
Yeah. Well, it's an interesting idea there, and we'll have to see how it turns out, you know?
Yeah. Well, assuming that it works okay, and I think it will at the end of the day, where I want to go with this is I'm very much into the idea of controlling a robot, like something on Mars, okay, at a long distance using amateur radio. So I could set up, for example, in the outback of Australia, a computer with, even a little robot of some kind, and then use amateur radio to control it. And I think that that's the sort of project that, could interest kids and help get them interested in amateur radio.
Yeah, that would be a very fun project and worth pursuing, very much so. Well, our friend John Baggett, K2BAG, I don't know if he's in the chat room here tonight. I don't think he is. But John stays on the road quite a bit, and his traveling companion, the Hat, is usually right there beside him. They were back on the road again here just recently. They left the 14-degree Fahrenheit weather in New York and headed for California. And he found Al Lasher's electronics shop. Of course, it looks like they sell Philips and ECG components there, which would be good. He said this was a jam-packed old-time electronic shop. I asked him, did he get anything? And he said, yes, he got a hat full. Congratulations,
It's a multi-use hat.
John. Yeah, I would like to know where Al Lasher's is, because I'd want to drop in there. I like going in these old electronic shops. You just can't find a lot of this stuff around anymore. But not to be outdone, our friend Ralph, and I don't remember Ralph's call sign right off. His hat has been on the move as well around. There's Ralph's hat right there. Last winter his hat was in this same location. He's in Maine, and it looks the same. A little different angle, but it was snowbound last year. It is snowbound again this year.
That is a lot of snow.
That is a lot of snow.
The hat might have to be de-iced before it leaves.
Yeah, I think that maybe the hat, instead of using that shovel, should get a snow blower. It's good to see the hats again. What if you wanted one of those hats, Tommy?
You can get a hat just like that. You can go to AmateurLogic.Spreadshirt.com and you can get a hat. We've got Amateur Logic hats. We've also got some Ham College swag out there at the Spreadshirt shop as well. So look around there. There's bound to be something that you like.
Bound to be. I know there's something there that I like, and I've got some items from there. But I don't have a hat yet, and I feel kind of embarrassed that I don't, I really should.
I don't have one either, and I guess I need to get one.
Yeah, I'm gonna have to.
Look like they have a great time.
Yeah, it looks like it'd be a good travel companion too, as much as you're on the road. Okay, we're going to be back in just a minute because Emile wants to. When you can't talk about anything else, you can talk about the weather. So we'll be right back and find out what he's up to there.
Happy New Year's from Icom. Start the new year out with a bang with one of Icom's new available products. Communications have never been so fun. The SDR you've asked for is here. Icom's new 7610 is a high-performance RMDR with the ability to pick out the faintest signal, even in the presence of stronger adjacent signals. The new Icom IC7610 is a direct sampling software-defined radio that will change the world's definition of a SDR transceiver. RF Direct Sampling System, 110 RMDR, independent dual receivers, and dual Digicel. ID31A Plus, a new D-Star communications device, is here. Easy to operate, the ID31A Plus is available in silver, red, or gold. Worldwide digital communications. Share pictures and text messages. IPX7 waterproof, compact, lightweight, and tough. Visit IcomAmerica.com/amateur for more information on all the great Icom radios.
All right, on your email stack here, Tommy, you've got one here. We've had this request quite a bit recently. Do you want to give us some pointers?
Yeah, I've got one, and you're right. We have gotten this one quite a bit, so I thought it'd be good to cover it one more time. I got one from my friend Bob, KK6YLW, and he's not the only one that sent this basic email in lately. So, anyway, he says, one of my resolutions for 2018 is to watch AmateurLogic.TV episodes live and participate in the chat room. My only problem is that I never know when the broadcast will be live, so I've been reduced to watching them in rerun without chat capability. I've searched the website looking for a schedule. I do want to get them put in my calendar so I'll get a reminder to be at the computer in time. I'm on the West Coast, so be sure to enter allowing for time zone differences. Can you point me to the right link on the web page or the schedule? So anyway, unfortunately, we don't really update the web page for that. I guess we probably should. The Amateur Logic ones are usually the Friday night before the 15th of the month. Now, that does vary a little bit, but we always post them to the social media outlets, always. So they're always on the Facebook Amateur Logic and Ham College groups. They're on the Google Plus Amateur Logic and Ham College groups. And if you subscribe to the Twitter accounts, Amateur Logic or Ham College, we always post it on there as well. We post them about a week ahead, and then a day or so ahead, we usually put a reminder. And then within an hour or so before we start, we actually post another reminder. So the best way is to subscribe to some of those social media outlets, and you won't miss one of them. So anyway, I hope that helps. If you have trouble finding the right places to subscribe, send me an email, Tommy@AmateurLogic.TV, and I'll be glad to send you some links to where you can go and look at them. So, and I hope that helps. But anyway, you're right. We have kind of gotten a lot of those here recently, so thought it'd be a good idea to go ahead and touch base on that one more time.
Yeah, I noticed Don in the chat room had said maybe a Google Calendar would allow people to subscribe and alerts, but I think, and if we can come up with it, something simple, because, like in this case, he didn't, Bob doesn't do any of the social media stuff, so he doesn't have any accounts there. He may not have a Google account or be into using Google Calendar and such. I don't know if there's some other way. We'll have to do a little thinking there, because I believe, there would be more people here live if we had a better notification system.
Yeah, we might be able to do an email list. I don't know if people still subscribe to those things or not. I get so many junk emails. I don't really want any extra emails myself, but some people may. So I may look into doing something like that.
Yeah.
Twitter's nice because you can have it actually send you, pop up a notification for certain people. You can subscribe to their tweets.
Yeah.
And we don't really tweet a lot of extra things on there, so there are almost always notifications on the shoots.
Yep. Emile, you've been concerned about the weather. Tell us what's going on.
All right, George. Well, going into my 11th year as being a ham, there's one thing I've learned in that 10 years of operating is hams love to talk about the weather. Every band, every mode, digital, voice, doesn't matter. Somehow the temperature makes it into that thread or discussion. So, at Amateur Logic, I'm still an amateur, especially when it comes to science, the sciences of weather, and I don't claim to have any answers or anything. So I decided to throw my hat in that ring of amateur sciences, and there is a project called Coco Rejas, and of course the weather stations, and that's what this is about. Plus, we got to play in the snow in southeast Louisiana, so it's always good when that happens.
Yeah, I agree.
Hey, George, Peter, and Tommy. Picked a good day to cover this topic. As amateurs, we all want to, or some of us are weather enthusiasts, I'll put it that way. And there's some projects out there that you can help the community, in your community, or the government and other agencies collect some data that are relatively cheap to get started. One of those projects is called CocoRahs. That's CoCoRahs.org, and basically it's a volunteer network to capture the scientific data to measure precipitation. There's a lot of information on the site on how to actually get started, but the very first step is to obtain one of these cylinders or rain gauges that are CocoRahs devices, or something that's trusted by them as far as collecting information. So lots of good training information on their site to get started. Along with that comes a network of volunteers for your state or region within the state that are all equal enthusiasts and decided to take a leadership role to help people in their states and regions. On the site you can establish your station's location, and they'll assign you a station number so that they can track the precipitation you record over time. A pretty neat feature of it is you can always view your data in near real time on their site, and you can actually go in and zoom in on your area's location to see what other stations in your area might be actually reporting, as far as that goes, to get an idea if you're in the right, if what you're recording is what other people are seeing as well. There's also a mobile app to help enter your daily data, and you just walk out, read the gauge, put it in here, and it updates your station information. So for about $30 you can start your own version or station within the system, which is definitely cheap old man compliant, and start entering data. Of course, there are also ways to integrate other more elaborate stations or for you to read data, but they're not exactly cheap old man compliant. Like this one here from my fellow ham, who's got a Davis WeatherLink station and system set up, and I also have one too that does some of the automated reporting and things. You can even integrate them with APRS. You can see all of these WX stations out here. They're all putting data out there so that you can go and check them either over RF or through APRS IS, the internet connection for ham. So ham radio is definitely a part of this, but as an amateur scientist, it's a good way to participate in communities.
Very good there, Emile. What have you been able to forecast yet? I'm just wondering.
No forecast. I mean, I do have one of the weather stations that does its own forecasting, but that's not the cheap old man variant that I just showed everybody. And it is I did get to learn something about the water, the way they, since it snows very seldom down here, I got to learn how you melt the snow and then add that into that system. So, it's always room to learn something. It's kind of like ham radio, which is why it attracts me.
Well,
Yeah, the weather's cool. It's always fun. I've always been fascinated by it.
well, you've got a social media post here that it's kind of a timely topic, isn't it, Emile?
There's posts on our Facebook from David Richardson in Kentucky, I believe, W9 KHC. And he wrote to us, remember, everybody, Winter Field Day is January 27th and 28th. Emergencies happen in the winter too, so let's be prepared. Grab your gear and heaters and get on the air. It'll be fun. Their club, K4KJQ in Kentucky, will be set up at their Kentucky Horse Park campground in the primitive camping area. So I don't know that I'm going to say it sounds like fun, but I get it, and that's a good thing to know what to do, how to operate in adverse conditions, if you will.
Yeah, that brings a whole nother set of challenges than doing it in the summer in the extreme heat. Your batteries aren't going to hold up as well. Solar stuff's not going to be as good because typically you don't have as much sunshine. So
Yep.
it'd be it's a good exercise. I wouldn't mind doing it. It always falls on the same weekend as our Hamfest here, though.
Yeah.
Yeah.
Yep, that's the problem here. We've talked about doing it before, particularly that's a subject that comes up during the regular field day every year. Boy, it's so hot. We need to do this in the winter. Well,
Yeah.
somebody's got an answer there. Thanks for that post, David. And we have thought about it, but just the dates don't line up here. Tommy, you and I were talking about your video here a little earlier, and you're starting to get a little heavier into electronics now and doing some experimenting and stuff. What are you going to show us tonight?
Yeah, I have been. I bought an oscilloscope and been doing a few projects and a little Arduino stuff. And I ran across the website. It's actually a site that I've shown you before. Well, here, let's look at the video, and I'll tell you a little bit more about it when we return back from it. Well, I had previously planned on doing a project with my SDR Play RSP2 that I picked up in Dayton last year, but I'm going to save that for next month. I ran across a pretty cool website. If you remember a while back when I got my 3D printer, I did a little project using Tinkercad. Well, I was going to do something else on there, and I noticed Tinkercad has an electronics part in there now. So you can go in and design electronic circuits and so forth and test them. You can wire up your projects, do measurements, a lot of pretty cool stuff, and I thought I'd show you that. This is kind of more geared for the electronics newbie, kind of like myself actually. Even though I've been a ham a long time, I haven't really done a lot of projects. I'm just kind of starting to get into it. To start, we log into Tinkercad, and you can see the 3D design stuff on here, but we're going to go into circuits. So let's go in and make a new circuit, and it'll show you the components that come up selected. There's a lot of things that you can use. We've got resistors, LEDs, caps, batteries, Arduinos, diodes, lots and lots of things. If we go over into all components here, you can see that there are even more. Photodiodes, power supplies, function generator, oscilloscope, a lot of ICs, just a lot of different things that you can do with it. So I thought I'd kind of show you a quick rundown of it. If you remember last month, I did my little project with my Arduino Pro Mini. It was actually to show the power board, but I made a little sketch, threw it together that just did pulse width modulation to flash the LED, and then it blinks the onboard LED. Nothing magical there. I almost hate to show another blinking LED project, but I just so happen to have this handy, and we're going to try to duplicate it real quick on Tinkercad. I'm going to take the same code that's actually running on this Pro Mini, run it in the emulator here, and we'll see that we get the same results, and we'll look at it on the oscilloscope as well. So let's go ahead and get started. I want to go ahead and add some components. I want the Arduino. I'll go back to the basic one so I can find them. We'll put the Arduino. This is an Uno. It only shows the Uno and the AT Tiny on here. I'm assuming at some point they'll probably add some others, but my code is 100% compatible from one to the other. And we're going to need an LED for this. Helps if I click on it. I think I'll put it on a small breadboard just to make things a little bit easier. So we'll drop it below there. Let's put our LED on the breadboard. I'll put it up here at the top so it takes as little space as possible. We're going to need a resistor. If you remember recently we were talking about this, that it's best to put a resistor on there to keep from drawing too much current from your Arduino and causing a problem with blowing out one of the pins. So let's go and add a resistor. Here's one, and we'll put it right here because it's going to connect that way. What we're going to need to do is rotate it though. So let's go up here to the top and we'll rotate it and move it over to where we need to go. Now we've got our anode and our cathode of our LED. The anode is the positive side where our current is, and this is going to be back to our ground. You can see when you hover over this that these pins are all connected vertically right here. So anything we connect here, if you haven't used a breadboard before, of course, anything we connect here is going to be in the circuit with that pin right there. Anything we connect to this one's going to be with that one. So let's go ahead and do this. This is all we really have to make the project. So I blinked the internal LED and then I did pulse width modulation on this one. So what I'm going to do is bring up my code that I used before. This is exactly the code that's running on this little project here. As unimpressive as it is. So let's copy it. Let's go into the code editor here, and you got a block mode or code mode here. And what I'm going to do is just erase this code right here, and I'm going to paste mine in. And what our code does is it sets LED pin number 9 to hook up to the LED. The internal pin is using this constant LED built in. So no matter which Arduino you use, if you use that constant, it knows how to address it. The compiler knows how to address it. So we're going to go through our loop here, and we've got another for loop here that's going to actually raise and lower the duty cycle for pulse width modulation. We'll talk more about that in just a moment. And there's a slight delay in here so it doesn't run too fast, and you can actually see the light fade on and off. When we get through with the one fade cycle, I just decided to put a flash in here just for the heck of it that lights up the internal LED, and we're going to use that in a minute. There's a purpose for it. So let's go ahead and upload that code to our Arduino. Now it's actually running because we should see our LED flash right here, and we do see it flashing, but we don't have anything hooked up to these pins to see the external LED. So let's go ahead and stop our simulation. So what we'll do is we'll go from here, terminal 2, we're going to take this up to pin number 9, which was defined in our code, and we're going to also bring our ground up and over. Get out of the way of that. Bring it down here and we'll hook it up right there. And we can change the color of the wires. I'll make that one black because I typically make those black. This one I'll make it red because typically that's what I'll use for my power line on my DC projects. Now this should run, the code should send the pulse width modulation here through the resistor, lower the voltage enough for the LED, and also keep from blowing out our pin on our Arduino, and then run. So let's go ahead and see what it looks like. Okay, and it's running, and you can see our LED is fading on and off, and our other one, built-in one, is flashing after the cycle of this. So that's all fine and good. But let's do some other things. We want to see what pulse width modulation looks like on an oscilloscope. So let's go back to our components. And let's see if we can find one in here. Here, this might be fun also. Let's go ahead and put a multimeter up here too. So we'll put a multimeter up. And let's find our oscilloscope. I know it's under all components somewhere. Here it is. And we'll just drop that right there. Okay, and let's get rid of our components. So what we can do is, let's take a look and see about the voltage here. Let's use a multimeter. We'll hook it up to our negative, and I'm going to try my best to keep this stuff out of the way as much as possible. And I'll just hook it up down there at the bottom. And I'll make this one black again because that's our negative. And we'll hook up the positive side. And what I want to do here is I want to go over and I want to measure the pin 13, which is the one that's wired to the internal, see how many volts are coming out. So what I did was I hooked up pin from the positive here for my voltmeter up to pin 13, which is the one that's wired to the internal LED, and I want to see how many volts are coming to this pin. So let's run that. Okay, starts out with 0 volts, and 4.7 is what shows up right there. So that's fine and good. Our oscilloscope's not hooked up yet though, so let's hook it up to a negative. And we'll use the same line here and make it black. And then our positive probe, we'll take it over here and we'll hook it up in line here. Now this is, actually let's do it right here because this is the safer one. This is the one that's after our resistor, so after our voltage has been reduced a little bit. So let's go ahead and take a look at that. Well, look at there. We can see pulse width modulation right here. So what that is these high points and low points are called the duty cycle. That's the spacing between on and off. So that LED's actually flashing on and off so fast that your eye can't detect it. But it looks like we're raising and lowering the voltage of it. But in fact, it's constant. We can see according to our oscilloscope that this is a 10 volt scale, and if we zoom in a little bit we can see 1, 2, 3, 4, 5. So there's each one of these segments is 1 volt, and if we look at this we can see we're getting about 2 volts on the other side of the resistor. Just out of curiosity, let's see what we get prior going to the resistor. So we'll take this lead and we'll move it over here to this side of the resistor, and let's run the same thing. If we look at the scale here, we can see it changed to 20 volts for the scope. That means 2 volts per segment. So that's 2, 4, or almost 5 volts here of this side of the resistor. So we can actually see the effect that our resistor has on our voltage. We can change the value of this resistor on the fly. So we're back down to 10 volts, so that's 2 volts of voltage we're seeing. And we can go right here and change the resistance to ohms. This should be 220 ohms. I didn't set that prior, so that's my mistake. So 220 ohms, and we've still got tad over 2 volts. If we want to change that to 440 ohms, we can see it drops down a little bit more. So anyway, you can see the effect that you have. You've got a lot of pretty cool measurements you can have. Let's see what it looks like on a real oscilloscope compared to this one. So I'll go ahead and set this resistor back to 220 ohms like it should be. And let's run our simulation. And we can see our pulse width modulation here. Let's zoom in a little so we can see it better. And you can see on the superimposed video here that our pulse width modulation is essentially the same thing we're seeing. So while the resolution on this is not real fine, it does give you a good idea of what your code is doing. So anyway, I hope you find it useful. I've been playing around with it a lot in the hotel room, doing a little experimenting. I thought the pulse width modulation stuff using the oscilloscope was pretty cool. There's some other emulators out, but this Tinkercad stuff just seems pretty cool to me. I thought maybe some of you guys might enjoy playing around with it, prototyping your projects and doing a little learning. Also, speaking of learning, I didn't show it, but there's a lot of lessons on here that you can run through to learn some more about electronics as well. Anyway, I hope you guys find it useful, and I will see you next time.
I knew what Tinkercad was, but I really haven't looked at it. I didn't know that you could do the virtual scope and all that kind of stuff with it. I can see it being very useful.
That's what I thought was kind of cool. So you can do measurements. They've got a constant current power supply on there. You can use adjustable voltage and set up a lot of things. And it doesn't have to be Arduino. You can do just any electronic projects.
Yeah.
I just did the Arduino because I happen to have that one sitting there, and I could show a real scope and the virtual one and show the differences in them or the similarities in them. So anyway, it's a good learning tool if you're trying to get started in electronics and you don't have a lot of tools and a lot of components. You can prototype your project there and learn a lot about electronics. So it's pretty neat in that regard.
Yeah. Peter, what have you got in your email or social stack there tonight?
Well, actually, I've got an email from our friend John Baggett, K2BAG. And in the email, he asked about the School of the Air, and whether we might do a segment on it. The School of the Air is very famous here in Australia. Basically involved the use of two-way radio to teach kids in very, very remote locations, like out in the centre of Australia, and to give them an education and also to a certain extent a social life with other students. And that's been going for many, many decades and still continues today. I did briefly touch upon it when I did a visit up to Broken Hill in episode 23. I'm unlikely to be heading up that way again, so it's not easy to do a segment on the subject. But I will mention, though, that we've had a little bit of news just in the last month or two. The West Australian government, because a lot of this is state-based, announced that they're actually going to cease or stop the School of the Air in West Australia. And this caused a big hue and cry, and there was a lot of people complaining about it. And it's just been announced that they decided to change that decision, and the School of the Air will continue in West Australia, which I think personally is a great thing. And it's. I should also mention that these days they've moved away from using two-way radio, and now we've got the NBN, or rather satellite internet, that enables kids not only to talk to each other and to their teachers, but also to look at video and see each other. So the technology has progressed significantly.
That is quite interesting. You know, we don't have anything, I don't think we ever had anything like that here in the U.S. Because, I mean, there are some areas that are not very well populated, certainly in the States as well. But, you know, I know in Australia you really got some folks separated from everyone else out there. And the radio, boy, that just seems like a very good way to do it, you know, in decades past when, you know, where it wouldn't be practical to actually build a school and teach students.
Absolutely, George. And let me give a bit of perspective for those that are unfamiliar with the geography of Australia. First of all, you can take all the countries in Europe, and you can, if you just drew an outline of it, you can fit that within the outline of Australia. So that's the first thing. Second thing is that most people in Australia live along the east coast and to a lesser extent down on the southwest coast. Most of the inland of Australia is dry, arid, and not very, shall we say, hospitable to life, okay? And to give another example, a few years ago I drove from South Australia across to West Australia. I drove 15 hours non-stop at 100 kilometres an hour, and I would not have, I'm just thinking back, no, I wouldn't have come across a town with more than 1,000 people on the entire route from memory. So that gives you an idea of just how unpopulated the centre of Australia actually is.
Wow, that is, you know, it's something we don't think about here, but, you know, we have deserts and areas like that that are not very populated, but, you know, 15 hours, that's a long drive to go through such small towns.
Yeah, and if for anybody who's ever actually doing that drive, which is from Port Augusta across to, I forget the town at the other end of it over in West Australia, but at one point in time, when you're driving across there, you cross an area called the Nullarbor Plain, and the Nullarbor means no trees, and that's exactly what it is. You look out in every direction, and it's just low scrub, nothing more than a foot in height, and you can't see any trees anywhere, perfectly flat. So it's quite an amazing trip.
Yeah. Okay, we're going to be back in just a moment, but first, we've got something new from MFJ here that's kind of interesting.
There's a new ultra-portable multi-mode QRP transceiver on the air, and MFJ is the exclusive authorized North American sales and service distributor. The Zygu 5105 is a super lightweight portable transceiver perfect for handheld use, but with the features you would expect from a full-size rig. The Zygu X5105 includes a high-capacity 3800 mAh rechargeable battery pack for 5-watt operation on all HF bands plus 6 meters. You get single sideband, CW, AM, FM, RIDI, and PSK31 modes. Marketed exclusively in the U.S. by MFJ, carrying the Zygu X5105 is like having a sophisticated, full-size rig right in your pocket. Features include a built-in, highly efficient automatic antenna tuner, split-frequency transceiver function, RIT, noise blanker, digital noise reduction, notch filter, and computer-aided control functions. The general coverage receiver covers 500 kHz to 30 MHz plus 6 meters. Smooth digital tuning offers precise 1 Hz resolution. The large 3.6-inch LCD display with rich content makes operation a breeze. You also get multiple bandpass filters, selectable AGC speed, computer interface for digital modes, built-in keyer, CW trainer, multifunction microphone, VSWR band sweep function, and more. With the Zygu X5105, QRP no longer means sacrificing those convenient high-tech operating features that make ham radio fun. And you won't need to pack a bag full of cables and boxes either, because the keyer, antenna tuning unit, and high-capacity battery pack are all built right in. Visit MFJ Enterprises today and learn more about the new ultra-portable multi-mode Zygu X5105. MFJ, the world leaders in ham radio accessories at MFJEnterprises.com.
And that was quite an interesting looking radio. I did not get to play with it that much while it was here. I'm hoping to have one back soon. They had, a limited quantity in December, and with the holidays here, I could only keep one for a few days. But I did get on the air with it a little bit and talk to some guys that I usually run about 700 watts to talk with on 80 meters, and I talked with them on 10 watts. So
you're saying you didn't need the amp?
I'm saying they would have appreciated had I had an amp, but they could hear me on 10 watts. And it's a neat little rig. I'm not going to throw out my IC 7700, but for QRP now, that's...
Yeah, it's pretty cool. I could see that being like a good hotel rig or something for...
Yeah.
Looks pretty cool.
Could potentially be.
I like that it's got the antenna tuner built in, because means you can throw a piece of wire up a tree and away you go. And it's got the battery as well.
Yep. That very neat concept. I hope, like I say, I hope to get one back here to do a little more playing with, and maybe we can take a look at it in the future. Well, I had to come up with something for this month's segment that was... Obviously, I couldn't do anything with an Arduino because that had been covered pretty well. So I thought I would go old school. For those of us who have repaired electronics, done troubleshooting and stuff over the years, usually years ago, maybe the only piece of test equipment a technician might have was a voltometer. And that's all they would have. They wouldn't have an oscilloscope or anything else like that. And so they'd have to get creative on testing components with an ohm meter. So that's what we're going to take a look at tonight, and just kind of give you an idea of what you can do with a trusty old ohm meter.
If you were stuck on a desert island and you could only have one piece of test equipment, what would it be? Well, mine would certainly be a voltometer. And you've got a choice to make there. You can either have a DVM, digital voltmeter, or
You can have an old analog VOM. It really depends on what you want to test as to which one would be best for the job. I've always said in the past that I'd probably want my Simpson 260 here as my preferred piece of only test equipment. However, when I look in the toolbox that I carry with me on the job, I don't have one of those in there. I've got a Fluke digital voltmeter. So it's debatable as to which is best. If you want accuracy, then you probably want to go with a digital meter. If you want flexibility and fast response in your meter, you probably want to go with an analog. Let's just take a quick look here and see what I mean. I'm going to put both meters on the lowest resistance scale. On this one, it's the 200 ohm scale. That means the most it can read in this particular position is 200 ohms. This one is in the R times 1 scale. Now, the digital meter, it's ready to go. As soon as you touch those leads together, it's measuring. And it says I've got 0.1 ohms of resistance there in the leads themselves. You see I touch the leads together though, and it takes a moment before I see anything happen there. That can be a drawback. That's why I really like a good old analog meter in a lot of cases, this 260 being the standard. Of course, if you're going to measure resistance, the first thing you're going to have to do is zero the scale. So you touch your two leads together, then you grab the zero knob here and adjust it to that pointer is sitting right on the zero. Now you only have to do zero adjust when you're going to be using the resistance scales here. You don't need to do that for voltage or current scales. It wouldn't make any difference on them. But when I touch the leads together, look how fast the old analog voltometer responds. It's instantaneous. You can see it as soon as it happens. So that's, to me, is very handy in a lot of cases. There again, it's not going to be as accurate as a modern digital voltmeter. But that said, I just wanted to show you how to check a few common components if all you had was a voltometer. We're going to set the digital out of the way here, and we'll concentrate on an analog meter. The measurements would be performed the same with a digital meter, but it's just a little easier to see on the analog here. Now, if we're measuring continuity, which would be, real low resistance, then we'll use the R times 1 scale. Now, one thing you'll notice on the zero adjustment there, you short your leads together. If you change scales here, it's going to throw off your zero adjustment. So you'll have to recalibrate that each time you change scales. The first thing we'll check here is a piece of coax or a piece of wire. That's basically what coax is. So we're going to check it from the shield on the outside of each, if you can see what I'm doing there. And we're measuring 0 ohms there, which means that connection is made all the way through. There's no break in this cable on the shield. Now let's check the center conductor. Same thing, 0 ohms. So that's telling us that the center conductor is good. Now, we also need to check to make sure the center and the shield are not shorted together. To do that, one lead on the center pin, the other lead on the outside. You shouldn't read anything. Those two are not connected. If, however, when you do that, you see this, well, then you've got a bad piece of coax. Probably a bad connector on one end or the other. Now let's move on to something else that we can check quickly here, just simple continuity test. What if you had a fuse? This is the old style automobile fuses here, used in a lot of rigs still today. If you want to check that, well, you just take your R times 1 scale. You got a good fuse. You don't see any resistance in there. What about a switch? When the switch is off, you don't see anything. Turn the switch on, it ought to be 0 ohms. If we wiggle the switch a little bit and we saw that wiggling, we'd know that, maybe this switch needs cleaning, or maybe it's gotten old and it's just not that good anymore. I've got a 1000 ohm resistor right here. It's brown, black, red. So let's check that. Well, if we look here on the R times 1 scale, 1000 would be way over here. So we don't really want to do that. Let's move up to the R times 100 scale. Let's short our leads out there, and since we're using jumper leads now, we need to include them in there. Get her right on 0 ohms. Check our resistor. There you go. Comes right up to 10. 10 times 100 is 1000. That's 1000 ohm resistor, just as we expected. Now let's check another kind of resistor. This right here is a potentiometer, and a lot of you, probably most of you, are already going to be familiar with everything I'm talking about here, but there are a few people who aren't, so that's why we're covering this today. Well, let's check from one side of the potentiometer to the lead all the way on the other side. And we don't see very much there. This is supposed to be a 20k ohm resistor. So we're going to need to change scales here a little bit. Let me short my leads together again. Let's go up to the R times 10,000 scale. Re-0. Now let's measure across there. Well, it comes right up to 2, and 2 times 10,000 is 20,000. So that's what we'd expect. Now on a potentiometer, we can check from either side to the wiper there, and you can see as I turn it, goes on down to 20k. Turn it back, it's on 0. And you saw that's a good smooth operation there. No jerking or noise of any type in there. Doing something like that would be a little more difficult with a digital meter. It's easy to see though here with the analog. How about if you wanted to check a light bulb? How would you do that? Well, a light bulb's pretty low resistance. Let's go up to the R times 1 scale. Looks like it's on 2 divisions there, 0.4 ohms. A little less than half an ohm resistance. Now, one thing about light bulbs is if you're going to do some calculating to figure out how much current this thing is going to draw at a certain voltage, you can't go by the resistance reading we got here. As that filament gets hot in the light bulb, the resistance of it changes. But if you just wanted to see if you had a bulb that was open, quick continuity check will do it for you. Now let's move on to capacitors. Of course, I'd prefer to have a capacitance meter, but, I'm on that desert island, so I can only bring one thing. This is what I've got. So let's do some checks here. Here is a little capacitor here. This is a 0.1 microfarad. If we tried to measure across it, we're not going to see any resistance at all, and that's a good thing. This is a capacitor. The DC coming from this meter shouldn't be able to cross from one side to the other. Now, if we go on up in scale, let's see if anything changes there on our meter. R times 10,000, and you notice I'm reversing the polarity here each time I touch it. You can see you get just a little kick out of it. Now, if you were up in the picofarad ranges, you'd get capacitors so small that you just really wouldn't see anything at all in the meter. The only checks you could do is just to see if it's shorted by measuring across it. You couldn't tell if it actually had any capacitance, as evidenced by that kick there. Now let's go on up a little bit to, a 100 microfarad here. Let's see what that looks like. Still on the R times 10,000. Okay, that kicks on up. And it's bleeding down a lot slower. Now you can do this with a digital meter as well. Just a little harder to see this action taking place. And if I sat here long enough, I'd see this eventually bleeds on down to infinity, no ohms, which is what you would expect on a good capacitor. If it didn't, then that capacitor would be leaky, meaning that it's built up some resistance in there and is not performing as well as it should. Inductors. How would you check an inductor? Well, I think most of you can probably guess. That's just a coil of wire. I'm going to go up to 1 ohm there, or R times 1. 0 on my meter, and let's see. As you'd expect, very low resistance there. Now, there's no way we can measure the inductance with this instrument alone, so all we can do is tell that, yeah, there's continuity through the coil. We can't tell if any of the winding is shorted unless we knew what the resistance should be to begin with, and most of the time you don't on a coil. One more type of inductor, sorta. This is a transformer. You've seen these before in just about everything that runs on AC electricity. You know, there's a primary set of windings on here and a secondary set of windings. This one has a center tap on the secondary. How do we know which is primary and which is secondary? Someone was telling me the other day the lead colors might give you a clue. I'm not sure about that. Let's see if we can measure any resistance at all here on the primary. 200 ohms of resistance here on the primary. Now this transformer is supposed to step down, well, I've got written here on it, 11 volts AC is what I had on the other side of it. That's a step down transformer, so I'm going to guess resistance will be a little less here. Secondary there reads about 1.3, 1.4 ohms. Pretty low resistance, which is what I would expect. You know, the primary and a step-down transformer is going to have a lot more windings than the secondary. Now, what about this center tap here? Well, let's measure from one of our secondary leads there to the center tap, and it should be approximately half of the total there. So that looks like about 0.8 ohms. Let's try the other lead of the secondary to the center tap. A little bit less, 0.6, 0.7 ohms. So that center tap is not perfectly in the center on this transformer. Let's check from the secondary here over to the primary. You should have absolutely nothing there, even on the highest scale that you've got. If you do, then that transformer is shorted. You need to throw that one away. All right, let's move on to some semiconductors now. We can check a diode. Usually I'll check these on the R times 1000 scale. This doesn't have that. It has R times 100. We'll measure across the diode, and we've got nothing there. Let's reverse the polarity of the diode. That's about 650, 700 ohms because we are on the R times 100 scale. We're reversing the polarity. One way, we have nothing. The other way, we'll have a fairly low resistance. And that's what you would expect to see with a diode. Now you can also do this on some meters, like this one that has a plus DC and a minus DC. That's the same thing as reversing the leads when you flip that switch. Now, if you're going to do this on a digital meter, for a semiconductor, it takes a little voltage to trip that junction there. Usually most of these digital multimeters will have a diode scale there. You'd choose that to measure a diode. Now here's a transistor, and you know it's got a emitter-based collector on it. Well, we could sit here and talk about what should be reading which direction, depending on if it's an NPN or a PNP transistor. We really don't have to get that specific, just for doing a quick test and seeing if the transistor is good. Now you might be able to do this in circuit, but then again you might not. So we've got one out of circuit here. I'm going to clip on one lead, touch it. Okay, we see we've got, I don't know, about 900 ohms there. I'm going to use the same two leads, but I'm going to reverse the polarity. You notice now I don't have anything. All right, we should be able to repeat that using all the possible combinations of these leads. And here we can see that same thing. Reverse the leads. We got nothing. All right, let's try the last combination of leads from the outside to outside. Don't have anything that direction. Don't have anything that direction. So basically, if you're just wanting to check a general purpose transistor, 2 of the lead combinations, it should act just like a diode. One way low resistance, the other way very high or no resist, or I can't say no resistance, very high or infinite resistance. 2 of the lead combinations. The third combination, you won't read anything, even if you reverse the polarity. That's a good transistor. If you don't get at least 2 combinations there that give you that lower resistance reading, then the transistor's bad. If you reverse leads and it reads shorted both directions, that's a bad transistor too. One other component here. Can we check this? This is an integrated circuit. No. Well, I say no. I've never tried it. I don't think there's a good, reliable method to check integrated circuits with a voltometer. So you're out on that desert island and you're trying to fix your radio. It's a good thing you got your trusty meter with you, isn't it? You never know when you might be somewhere and all you got's a meter.
Yeah, that's good basic stuff too. I hear myself back. Anyway, it's good basic stuff to learn too, because kind of like my segment, it's good to remember. Not everybody's got the same level of skill and experience with doing some of these things. So it's good to go back to some of the basic things every now and then. We got viewers from a lot of different levels.
Well, that's true. That's true.
Absolutely, George. I mean, I know I started as in CETE at college, but we had the digital multimeters, but those analog meters, my grandfather had a triplet meter that he gave me, and we used them all the time, specifically to show that swing in some of the circuits we used to test, like telephones.
Yeah.
Systems in the circuits. So yeah, it's very useful.
Yeah, technology keeps moving toward digital, but there are some definite advantages to analog. Because the real world is analog. So.
Absolutely.
Yeah. Okay, well, that was fun, guys. I can't say it wasn't a lot of work over here. I've only got 2 hands, and I had to do about 5 things each time we changed from one thing to another. But is everyone still okay?
Yep.
I think we all survived.
Okay.
I have all my pieces.
Mm-hmm.
Yep.
So
For sure.
maybe the other hands will be back next time. Should be. So we'll be back to normal. I got the new video playing machine all set up. Wanted to try it out. A little disappointed we didn't get to use it.
And it really worked so well too when we tested it.
Yeah. Oh yeah, it did. It's working really good in the case on the bottom shelf over here by my feet right now.
Yeah.
But we'll try it next time.
Marty says there's no injuries in the chat room.
Okay, that's good too.
This is a good day then.
Yeah, you never know in there, man. Okay, before we go then, we do want to mention a couple of things here. We mentioned earlier how you can find out when we're going to be shooting the next episode of each show. And you can find out on our social networks there. Tell us about those, Tommy.
Yeah, like I mentioned earlier, both Facebook groups, AmateurLogic and Ham College, both Twitter accounts, AmateurLogic and Ham College, and we also have 2 Google Plus groups named, you guessed it, AmateurLogic and Ham College. If you have trouble finding any of those, you should be able to go to those services and search for them, and we should come right up. But if you do have trouble finding them, shoot me an email or one of us an email. We'd be glad to send you a link to it and point you in the right direction.
Yeah, I noticed John in the chat rooms there said he was injured. His mind was blown. John, check the fuse. Check the fuse. You know, I'm sure that's probably all it was.
Speaking of injuries, Tommy, over your left shoulder, I noticed there's an A hanging up on the wall, and I think you had some news about that A during the week.
Oh, man, there's A's all in this room. There's a giant one right up here. Yeah, but I don't think it's a big secret I'm an Alabama fan, so they won the national championship this week.
Congrats.
It's also on my shirt, too, so.
Well, very well done.
Yeah.
Yeah, you're not going to get an LSU fan to say it too often, but Roll Tide. But that was a good game.
Yeah, it was pretty good. It was pretty worrisome there for the first half, but it was exciting.
Where was the final held at, Tommy?
Pardon? Where was it?
In Alabama?
In Atlanta.
In Atlanta. Did you go to it, or?
Oh, no. I was at work at Dallas.
Okay. Would be good to be there, I reckon.
Yeah, it'd be fun. Maybe I'll get to go to one of these days.
Uh-huh.
Well, Tommy, any final words before we go? Oh, we do want to mention the next episode of Ham College will be shot toward the end of the month. We hadn't set a date yet, but hey, if you check those social medias or Twitters, you'll find out. Any final words, Tommy?
No, it's been a lot of fun, and looking forward to the next one.
Okay, Peter?
Nothing to add except 73 and Roll Tide.
Emile.
All right. Only thing I'm going to add is hope to see you guys out on the international grid chase. Been racking up some FT8. It's crazy on the bands right now, but between that and the NASA on the air, I hope to see y'all out there. 7-3.
Cool. All right, 7-3, everyone. And we'll see you next month. And don't forget, end of the month for Ham College.
7-3, everybody.
And I should turn the microphones up at this point.
That's what I thought was kind of cool. So you could do measurements. They've got a constant current power supply on there you can use.